And we're back. Back and better than ever. Oh, it's not going. Go, go! There it goes. Now, we are back. Back and better than ever. Back and better than ever. Hello. So, what I would like to speak authoritatively about, messages. A good, solid, positive message. How could I send a good message? I think art, and I'm kind of an artist. Kind of a self-proclaimed artist, underappreciated artist, that the boundaries, hello, how are you? The boundaries between art and engineering are only in our minds. So, what I would like to display prominently, show you some stuff. So, what do I want to show you? What would you like to see? Ask me anything that I know about. So, a lot of people out there, I think, struggle with depression. I've had moments where I've certainly struggled with depression. It's a challenge. Life is beautiful. It's a miracle to be here at all. It's amazing. Life is truly amazing. It's amazing. Life is a miracle. It's a miracle. It's a miracle to be here today, to exist at all. A human being. We have these little singularity generators. What is that? What is that inside that I call myself? Some like single-threaded thing. Me. I'm one thing. Some people say that the seat of consciousness is the universe. I'm the universe experiencing me. I'm the entire universe filtered through some guy, and it's like the brain, the human experience. A human being is a tuner for consciousness. I think you left. So, I guess what I'll probably work on now, on the subject of brains, these little oops, these little kind of some code for kind of deep learning. Deep learning is a hot topic in computer science today. What deep learning is has to do with artificial neural networks. So what an artificial neural network is, these kind of it's a lot to explain. I'll bring up this has to do with brains. These are tuners for consciousness too. I'm rather convinced. There's this book, Gödel, Escher, Bach, about strange loops and stuff like deep learning. My internet's a little slow. Oh, it doesn't fit. It's blocked. So deep learning, also known as deep structured learning, is part of a broader family of machine learning, something based on artificial neural networks. Let's click that. Artificial neural networks, it's it kind of a technology that's based on, well, I mean, there are a lot of different approaches to it. Artificial neural networks are meshes of units of simple functions, and you have all these little functions that are interconnected, and they feed into each other. So let's see here. I've got a picture somewhere around here. Looking for a picture for you. This is my secret blog. It's a little embarrassing sometimes. So here's a good picture. This is kind of what a artificial very bird, that was slow. Somebody, they I don't know. I guess I'm streaming video. That would slow it down. I guess I kind of like get this thought, like, is there someone assigned on, like, they don't know about Unix, but they know about a mouse on their computer, and they have a graphical user interface where they have to click a button every time that I request a packet over the internet. So they sit there and click the button really fast. Like, they have to approve all of my messages in my art. So they click a button really fast to allow each packet to go through. So anyway, that's beside the point. So these artificial neural networks, you can't see over, off the edge here where it is blocked by the chat window. But also, this guy, Mystery News TV, you should check out his channel. This dude, man, that this dude is an artist. He reports on mysteries, and he does a very good job. And it'll help you learn multiple languages about multiple subjects. Very fascinating subject material about mysteries, about the unknown. I would say pushing the boundaries of the unknown. This stuff, what's my channel is kind of just taking form now. I guess kind of just talking about stuff like stuff that I know about, like these artificial neural networks. So the little circles are like a mathematical function. Often, well, actually, no. There was a really yeah, 1984. Yeah, man. Oh yeah, dude, totally. So the 1984. That's about when this technology goes back to. The groundwork. There was something called backpropagation on nested functions to find the gradient of like a gradient is like the slope of a function, and in multiple dimensions. Like you have your mathematical function many people learn about in school, kind of 2D function with a slope, and you can generalize that to infinite dimensions, and they still have a slope called a gradient. So there's the backpropagation algorithm kind of is like rolling a ball down a hill in infinite dimensions, hypothetically, like an infinite dimensional hill, which is data science. Like you could have a dimension for well, I can't think of anything, but you could have a dimension. A dimension in mathematics is just a number line. Like you like a dimension is like a number line. That's about all it is. And you can represent data in multiple dimensions along, like you have the little points of data in some dimensional space, a data space. So like this input layer, like this could be like I don't know, like the color of the person's hair. This could be like how many times they've been arrested. This could be like how much money they have. This could be like how many YouTube viewers they have. This could be like they're just like numerical representations of data, like a number line of data. So you've got this mesh. These are like synapses. They're generally they're complete bipartite graphs between the layers. So they're fully interconnected. Each node is connected to all of the nodes on the next layer up. So then these connections, it says Wij, those are weights. So like those are the strengths, like just a multiplier. So like this is a function, and then it gets multiplied by this number, and all of these do, and all of these do, and then those inputs go to this, which is a function, and then that function, you know, just like a simple algebraic function like you're familiar with, like y equals x, like that's a pretty basic function, admittedly, but it really is about that simple. So then this function takes all these inputs and sends it to all these outputs, and what these were used for is pattern classification. So like you would give it a picture of like a cat or a dog, and it would figure out using this neural methodology, it basically would approximate of some very high level mathematical function about whether a picture is of a cat or a dog. And so you can solve pretty high level like thinking problems, like is this picture a cat or a dog? And these deep learning, as we call them deep learning backpropagation, often backpropagation. There are other training methods, but they would approximate some kind of function, like a mathematical function, that figures out if a picture is of a cat or a dog. So this code does that. It uses a few, it's actually, you know, this is actually for Linux. I'll show you on Linux. So this is just kind of a test program. So what it does, there's kind of this thing is good for testing these. There's XOR. So what XOR is just like a binary operation, a mathematical operation, that looks at two inputs, a 0 or a 1, say, and if they are the same, it puts out 0. If they are the same, it puts out 0. But if they are different, it puts out 1. And that's all it does. It's exclusive OR. It just says, if these two inputs are different, then the output is 1. Otherwise, the output is 0. It's exclusive OR. It's just a very simple, like a building block of digital logic. So, this is a good problem for deep learning tests because it's a simple problem to solve, but it is not linearly separable, which simply means if you drew out like a little picture of this, you can't draw a line to it anyway to separate all the answers. So it needs like actual deep learning to solve this problem. It needs what that means is it just has a hidden layer, as in that picture that I was showing. This actually has two hidden layers. that allow the function, it approximates the XOR function. So so when we run it, it doesn't do anything that spectacular for output. You see, like, error. The error is how far it is from the answer. So, like, the answer is either 0 or 1, and when it starts off, before it's been trained at all, it has an error of 0.677 something. All of them had about that. It rolls the ball down this n-dimensional data space to minimize the error as close to 0 as it can. Actually, it can get to 0, but we kind of, don't do that. Like, there is such a thing as overtraining artificial neural networks, in which case they become too, like, if you train it all the way to 0, then it might not work it may not work when you give it some kind of new data. It may be too fixated on the training data. Of course, with this, there is no test data. It's just, it's just solving XOR, not doing anything else. And when I get below an error of 1/10,000, it looks like, the program exits out. So, this is just kind of a simple, like, just kind of a for fun, from scratch, deep learning kind of thing, with some parallelization with OpenMP, Open Multiprocessing, which is really really handy to use with C. You just right here, you see, it's just got these little preprocessor definitions that you just sprinkle those into the C around the loops, and the loops become parallelized. Kind of maybe not very very advanced parallelization, but certainly easy to use. Kind of I think a lot of people like that. That's not quality software, I wouldn't say, and a lot of people I don't know. I mean, there's been this whole, like, argument, I think, it's online. The whole internet is just a big argument these days. But there's been this, these wild accusations thrown about that certain people are Nazis, or that people are bastards or whatever, fuckers. I think people are fuckers, but human nature is really I just had this really positive thought the other day that human nature can't be so bad, even if everyone's basically a fucker. Like, people are kind of fuckers. But we really have built this wonderful civilization where, we don't just get eaten by mountain lions. That's really, human nature is really pretty amazing and really optimistic, looking at that, from that kind of viewpoint, like, that's really optimistic. Like, I mean, all of these wonderful things in the world. I think humans are really pretty amazing fuckers. Great, I think it really bodes well for our future that we made it this far so fantastically too, to come out of the wild where we were just, prey animals, to start, wiping out saber-toothed tigers and stuff, and, really banding together to make this wonderful civilization with stuff like this, these interesting engineering marvels. And I think, minimalists like this is some accusation that, like, the Southwest community are Nazis. Like, people can be very rude. I think, a lot of the time, people have these, like, codes of conduct for software development communities to keep people from being just overly fuckers to each other. And, like, I'm not against that. I think, in a meritocracy, maybe not being a fucker should be considered a merit. But to, if you compare, like, the average programmer with Ken Thompson, like, I mean, people there. I mean, just because someone can program, like, most of us are really, like, pretty incompetent. Like, I mean, program, like, like, to be a master programmer like Ken Thompson, that's, 1 in a million. 1 in a million are that good. And those people should really be respected. But, I mean, people shouldn't just be rude. Like, it shouldn't, like, just being rude. Like, I mean, it hurts a little to have someone say, like, we're not going to accept your code, it's just not up to par. But, that's necessary to cultivate the absolute best product that you possibly can, to throw out a lot of trash that just isn't up to par. Like, a lot of things that I have done are, I'm still, certainly not Ken Thompson. I never will be. But I certainly would aspire to be that good someday. I guess it's enjoyable to, like, coding this was enjoyable. The process of it's not, it's not like the goal was enjoyable to complete this. Like, the actual, process of typing it all out and, like, getting it working, learning the mathematics behind it, was really, something that, I, wanted to do and had fun doing. And this really, is not, like, there's an artificial neural network library called libfan, Fast Artificial Neural Networks, and they do something that I haven't figured out yet, where they don't just seed the network with random values, they do some kind of, like, not quite random thing at the very beginning so that it'll train better. So, this doesn't do that, and it kind of shows that as a problem. But it was, it's fun to like, do this stuff. It's just kind of, like, I don't know, it's kind of like an art. I don't know, it's like bonsai. It's kind of like having a little Zen garden where you push stuff around. It is very Zen, I think. Well, I don't know anything about Zen. Might not be very Zen. But to get this running on Plan 9, I just got to make a few little changes, I guess. These printf. Plan 9 calls printf print. Actually, maybe a better way to do this, there would be less tedious ways of doing this. Taking out all the F's. So I'm not sure. It'll tell me. See, it gives me actually. I don't know. I'm just trying to get this to compile on Plan 9 here. Two to the 15th. What is that? Maybe that. Try that. I'm not sure if there's a no fmax function, so Oh no! That's looking promising. Promising. There it goes. So now, I've got, the same thing compiling in Plane 9. That was easy enough, I guess. Yeah, I don't know. These things are really interesting things. Now, you know, you guys, I don't know if you're watching. I'm gonna try not to comment on that. That people are fuckers. To recognize that you are a fucker. I am too. And I try not to be. Try very hard not to be a fucker. So, let's see. What I could show you. I have a little paranoia about the robot simulation. This kind of stolen robot simulation. I don't know. We say, you know, stolen. I don't know. Maybe stolen isn't the right word. You know, we have these twists of our vocabulary that are not very positive. Like this, that's not a positive thing to say. Like, you know, a lot of people, like it is harder, you know, in a chat room or something to just be civil and polite, and a lot of the time it degenerates into name calling, trolling, you know, people just trying to piss each other off, and it works, it really works, but I have this, you know, kind of a goal to counter troll, to counter troll people. You know, sometimes I feel really miserable and I just want to say something nasty, but you know, if I just you know, take a deep breath and say to someone like, I don't know, just something, the nicest thing I can think of, in no time, you know, everyone's happy, I feel better, they feel better, everyone's just like, happy as fuck. It really, goes a long way to just, you know, do the opposite of trolling, kind of like, not say something nasty, just like, you know, say not that, I mean, now everyone will doubt that my sincerity, that when I say positive things, but, you know, I, it's not about sincerity, it's, if people are just saying insincere things to piss people off in a chat room, I mean, what's, it's all, it's all bullshit anyway. Like, I am very sincere sometimes, but sometimes I'm just pissy or not feeling well, or just, it can be easy to just snap at someone when I feel like shit. And if I put a little effort into not doing that, but to say something more uplifting, then everyone feels better. So anyway, I'll be back in a minute.